Hello there. All right, so can you see the screen? Make sure we're good there. Awesome. Okay, so this is the stuff we were doing last time. This is just kind of a review of the same stuff and then a quick reminder because this thing shows up quite a bit. So as we discovered, the dreaded quadratic formula isn't really that dreaded. It's not that bad. And then we talked about something called the discriminant, which is just the stuff under the square root in the quadratic formula. Okay, so let's go ahead and do some more of the quadratic formula questions. So as long as you know the quadratic formula, it's pretty much plug and chug, right? All right, so let's check out a few of these guys. So we got the formula up here in the corner. All right, there's our guy. And the a, b, and c, a is the number in front of the x squared, b is the number in front of x, and c is just a regular number, okay? C is also the y-intercept. So anytime you have any kind of function, if you have just a regular number, that is always the y-intercept. Doesn't matter what kind of function it is. All right, so let's try these guys out here. All right, so we'll go ahead and split this up. Okay, so again, this is A. So A is 2, B is 9, and C is 7. All right, so we just go ahead and plug in the numbers. So if B is 9, that means minus B is minus 9. We do plus or minus. Long square root. So then we say B squared, that's 9 times 9. So that's 81. And then minus 4 times A, which is 2. And then times C, which is 7. And all that stuff is going to be over 2A, so that's just 2 times 2. All right. So again, probably our best standard operating procedure is to start with this stuff here. Okay. More accurately, the stuff that we're subtracting. So we'll do that guy next. All right, so if we multiply these three guys together, so I've got minus 4 times 2, that's going to be minus 8, and then minus 8 times 7 is minus 56. So inside here, we're going to have 81 minus 56. Let's go ahead and figure that out real quick. So we'll do 81 minus 56. That's 25. 25 is a perfect square, so that means this guy would have factored, but it wouldn't have been an easy factoring problem because we got the 2x out front. We'd have to figure out how things go from there. All right, so then that means we've got minus 9 plus or minus the square root of 25 over 2, right? And as we said, that would be minus 9 plus or minus 5, because we could take the square root of 25 and get 5 over 2. So that means our first guy would be minus 9 plus 5, so that's minus 4. So x would be minus 4 over 2, so that's just negative 2, right? And then the other guy would be minus 9 minus 5 more, so that's minus 14, right? So then that would be minus 14 over 2, which would be negative 7. Okay? So that would be our two answers for this one. Questions? Make sense? Okay, good. All right, let's go ahead and try another one here. So I noticed I must have hit the setting by accident. The writing's a little thinner. You okay with that, or do you like the thicker, heavier writing? I'm just asking, does it look okay for you guys? I can switch back to a little thicker writing if you like. You don't care? All right. I don't know if this is more readable or not, but let's try it for a little bit. And if not, we can always go back. All right, so then same deal here. So since there is no number here except a minus sign, A is going to be -1, right? And B is going to be 9, and C is going to be 5. All right, so we just start plugging in our numbers. So again, if B is 9 minus B is -9, plus or minus big square root. B squared, that's 9 times 9, so that's 81 again. Then minus 4 times A, which is -1, times C, which is 5. And I never make the square root sign big enough, it seems like. And all that stuff's going to be over 2 times -1. All right, again, so let's go ahead and start with these guys here. So I'll start with these three. So I've got -4 times -1, that's going to be +4. So the biggest thing here is to watch your signs. And then +4 times 5 is 20. So we have 81 plus 20, that's going to be the square root of 101, which I think we'll just leave that guy alone. So then this would be, whoops, this would be highlighter mode. That's what that would be. And let's fix that. All right. So then this would be -9. And this is plus or minus the square root of 101. If it had been the square root of 100, we'd have been good, but 101 kind of throws it off. But that's okay, we'll just leave it like that. And then all over 2. And I don't think we can reduce the square root of 101. I don't know of any perfect squares that go in there off the top of my head. So that's it. So it's kind of nice when that happens, because then you don't have to do any more work. It's all good. Questions? All right, let's go ahead. Do a couple more here. All right, so now this guy here, remember, in order for this to work, the one side has to be 0. So we got one extra step here before we really get into it. Okay. So what we need to do is we need to move this 4 to the other side. So that just means we're going to subtract. So we're going to have 4x squared plus 17x minus 9 equals 0. Okay? All right, so back to our formula. So again, A is going to be 7, or excuse me, B is going to be 17. So minus B is going to be -17 plus or minus 17 squared. I don't know what 17 squared is off the top of my head. I think it's 289, but let's not guess. Let's make sure. Nope, see, 361. That's 19, isn't it? Not bad, hang on. 17, there we go. It is 289, okay. So then this is 289, then times -4, and then A. So that's -4 and +4, so that's -16, right? So it's -16 times -5. So let's go ahead and do that. So we clear it out. And just to make it official, we could say -4 times 4 times -5 gives me 80. And then 80 added to 289. So that's 369. Okay. So what do we have here? I totally forget it was 80. And all that is going to be over 2 times the a value, which is 4. All right, so we get 369 here. So we got minus 17. That didn't work. Hang on. All right, so again, minus 17 plus or minus the square root of 369 and then over 8. All right, so 369, 3 will go in there, so let's maybe try 9, see if 9 divides in there. See if we can do that. So if we do 369 divided by 9. Oh, cool, that works. Okay. So it's 41. So then what you do is you rewrite this part as minus 17 plus or minus, so it's going to be the square root of 9 times the square root of 41. And again, over 8. Yeah, line wasn't too good, was it? Hang on. Fix that up. Go away. There we go. All right, so plus or minus. Let's move that up a little bit. All right, we'll get this fixed. So plus or minus, and then all that is going to be over 8. That's a little better. So again, the reason we do the square root of 9, we pulled out the 9, is because the square root of 9 is just 3. So again, not a pretty answer, and that's all we can do to it, really. So x is finally going to equal minus 17 plus or minus 3 square root of 41 over 8. I know I'm kind of cramming it in there, but that's your guy. Questions? We still good? Chloe, you get the boot? What happened there? Happens to the best of us, kiddo. All right, so let's do another one here, since we got it staring us in the face anyhow. All right, so let's go ahead and switch up colors just for the heck of it. So again, this will be A, 5, B, 10, C, 7. All right. So again, we start with minus B, so it's going to be minus 10 plus or minus the square root of 10 squared. So 10 squared is 100. So again, so 10 squared is 100. And then minus 4 times A, which in this case is 5, times C, which is 7. And all that stuff is going to be over 2 and then times 5. Okay, cool. Okay, so again, let's start with the stuff on the square root, particularly these 3 numbers. Let's multiply these 3 numbers together first. Oh, no, I credit you for attendance, Taylor. Don't worry about it. We've all had our computer issues here. Trust me. So you're good. All right, so again, let's multiply these 3 together. So I've got negative 4 times 5. That's minus 20, right? And then minus 20 times 7 is minus 40. So we're going to have 100 minus 140. So we got a negative under the square root. That's different. I don't think we've had that before, but that's okay. We can live with that, and we'll show you how here in a second. So now we've got 10, and now we've got highlighter mode is what we've got, as usual. All right, so back to what we were doing. All right, so we're going to have minus 10 plus or minus the square root of minus 40, which technically we can't do that, right? We know that. But we're going to talk about how they represent this sort of thing, and that's going to be over 10. Okay, so here's what we need to do. Maybe I'll bring up an extra sheet here, and we'll discuss just the square root of minus 40, what we're going to do with that. So let's do that. So we've got the square root of minus 40. Okay, so as you're well aware, we take minus 40 and put it in our calculator and take the square root. Our calculator gives us the cyber finger, right? It says, nope, invalid input. Sorry, try again, right? Okay, so we knew that was going to happen. So technically, you can't take the square root of a negative number. Okay, so what are we going to do with this? So at some point along the line in the history of math, I'm not quite sure where. I'm sure it was probably hundreds of years ago, maybe even thousands, who knows. Anyway, someone decided, I want to take the square root of negative numbers. They're like, dude, you can't take the square root of negative numbers. No, I want to do it anyway. So what we're going to do is we're going to have what we call an imaginary number. You know, I don't know my personal preferences. The guy probably had imaginary friends too, but what do I know? So here's how they do this. They came up with this idea, and they said, well, what if we say that the square root of minus 1 is equal to the imaginary number I? Yeah, I know. You'll call the wagon now, right? Because this guy's crazy. All right. So what we would do here is, and we also know if it was just the square root of 40, we say, okay, we could reduce that square root because 4 is a perfect square. So here's how we would rewrite this. We would write this as the square root of 4 times the square root of negative 1, and then times the square root of 10. Okay, so 4 times 10 is 40, and then the negative 1 makes it negative 40. All right, so the way we'd write this, we say, well, the square root of 4 is just 2. By definition, this square root of negative 1 thing, they're just going to call I. And then we've still got the square root of negative 10. Just when you thought numbers couldn't get any weirder. Here we go. All right, so what can we do here? So we go back to what we were doing, back to our regularly scheduled program, and we're going to take this guy and plug him in. So we'll go back here. So then this is going to become minus 10 plus or minus 2i times the square root of 10. A lot of 10's going on here. Over 10. Okay? So then what we can do, let's make sure we get a dot there so we know that's not 21. Okay? Is everybody is an even number, so we can go ahead and divide everybody by 2. So negative 10 divided by 2 is going to be minus 5. And then plus or minus, now we're just going to have the I there. And then the square root of 10. You don't divide the square root of 10 in half. You leave that guy alone. And then over 5. Okay, that answer is perfectly fine. However, since the first two numbers match up, minus 5 and 5, they might, not necessarily, but they could maybe write this as minus 5 over 5 is just going to be negative 1, but then they'd write plus or minus I square root of 10 over 5. They might write it like that. Doesn't mean they will, but they might. Okay? Sometimes they get weird like that. I only point that out because, like I said, if you happen to be taking some sort of standardized test where you have multiple choice answers, you may come up with this answer. And again, that answer is perfectly fine, but you may not see that answer. But don't panic. look for something like this, where they just like basically put the 5 under each term. So if they put the 5 under here, we got -5/5, that's the -1. Okay. And then the other part they just left. Okay. Questions? All good? Okay. All right, let's see what we got now. Okay, so the next part here, it says solve each of the try that again. Solve each equation using the quadratic formula. Round to the nearest hundredth. So this time they actually want an answer, as opposed to all that square root stuff. So that's cool. We can do that. All right. So we're still going to do the same stuff, right? We need this to equal 0, so that means we got to go plus 11 here and plus 11 here. Cool. So we'll go across, we've got -6x squared plus 5x, and that and then plus 9 equals 0. Oh, I thought of something. Let's back up real quick. Beep, beep, beep. So what this answer means here with the I in it, that means there's no real solutions. There are imaginary solutions, or sometimes they're called complex solutions. But no real solutions mean basically, a quadratic graph is U-shaped, right? So in this case, what's going to happen is you're going to have a quadratic graph, and positive x squared means it's going to be a U-shape, right? It's going to be a right side up U. But then it's never going to touch the x-axis. Okay? So that's why it is an imaginary solution. When you have a real solution, that means your graph is going to dip down and cross the x-axis. And we're going to talk about that a little bit more when we get into the discriminant, but I thought I should probably point that out before we moved on. All right. So back to our regular scheduled program. Get this thing to move. There we go. Okay. So again, this time we don't have to worry about reducing the square root because they literally want an answer. So we can just take the square root and get our answer. So again, we've got our same guys we've had before. So A is -6, B is 5, C is 9. All right, so we'll use our formula once again. So minus B this time is going to be -5, plus or minus, then we got 5 squared, so 5 times 5, 25, and then minus 4 times A, which is -6, times C, which is -2. Okay, lots of negatives here. So again, let's start with these guys. Start with these 3 guys right here. All right, so this one, we've got -4 times -6, that's -24, right? And then we've got positive 24, excuse me, times -2 is -48. So what we got underneath the square root then is 25 minus 48. So here comes one of those negatives again, right? Okay, so what this is going to look like, oh, I forgot, all over all over a lot of yellow here. Hang on. Let's fix that up. Okay. All right, so then all this stuff is going to be over 2 times -6. Okay, so again, we're just plugging into the formula. It's all good. So now we've got -5 plus or minus the square root of -23. And then that's going to be over about -12. 12. All right, so this one here, I'm a little surprised they put this problem in this section and said round to the nearest hundredth, because we get an imaginary answer. The only thing you have to do to change this answer is, since you have a negative sign, the way you can take care of negative signs, anytime you have a negative under a square root, get rid of the negative sign and bring an I out front. So that's what we'll do here. So we got minus 5 and then plus or minus I times the square root of 23 over negative 12. Now again, I said I was kind of surprised that they put this under this section, because, like I said, you have this imaginary answer. What they were going for, I thought, was just taking the square root of 23 and figuring out what approximately that is. Okay, which we could still do. So we take our calculator here. So we don't want negative 23 because that'll give us a bunch of crap, right? 1 times 1 negative, so that gives positive 23. And then we take the square root of 23. Now we know the square root of 25 is 5. So the square root of 23 is going to be something a little bit less than 5. And again, it kind of helps to have an idea where this thing's going to end up. So we go ahead and take the square root. And as you can see, 4.79. We'll call it 4.8. I'm cool with that. Okay. And a lot of times with these sort of problems, they will instruct you if they want it rounded to a certain amount. Well, they said to the nearest hundredth. Well, since it's 0.7958, we're closer to 4.8 than to 4.79. So the nearest hundredth would be 4.80, just to prove that we did the extra decimal. Okay. So then what this thing would look like is, again, it would be equals negative 5 plus or minus, I'm not getting that plus sign in there, am I? All right, one more time. Close enough. All right, so then it's going to be about 4.8. Like I said, you can throw the 0 in if you like. I. So 4.80 times I, and then all over, if I can cram it in here, minus 12. I don't know what happened there. It's called, I don't have enough space here at the bottom. That's what it's called. Not sure where some of these string marks are coming from. All right, so again, it's negative 12. And that's it. Okay. So this one, rather than leaving it as a square root of 23, they approximated it as about 4.8. Questions? All right. So go ahead and check out this last one here. So again, same deal. We have to go ahead and add 3 to both sides, right? So that'll give us minus 2x squared plus 4x and then plus 12 equals 0. Got to equal 0 or the quadratic formula does not work. Okay? So that's one little stipulation we do have. All right, moving on. So again, we identify our guys. There's A, there's B, and there's C. Plug and chug time, right? So we say minus B is going to be minus 4, and then plus or minus B squared, so that's 16. Right, then minus 4 times A, which is negative 2, times C, which is 12. All that stuff, and then all that stuff is going to be over 2 times A, which is minus 2. All right. Let's start with the 3 numbers again. Choose a good place to start with these 3 guys. All right, so this time we've got 2 negatives. So that's going to be a positive. So what we need to do is we need to multiply 4 times 2 times 12, because we can just cancel out the negative signs. Let's move them over here. So we do 4 times 2 times So that's 96. And then we got plus 96, and then we're going to add that to 16, right? So our guy's 112. Okay. So let's go ahead and rewrite that. So this will be minus 4. It'll be minus highlighter in a second. We'll get rid of this guy. All right, there we go. All right, so we get minus 4 plus or minus the square root of what we said was 112? Forget. Yep, 112. And then all over negative 4. Okay, so the only thing we can do, well, we don't have to do it here because they said they just want the square root, so we don't have to do that. All right, so here's how we do this. We're going to do minus 4. Get our calculator out here. So we do minus 4. Then plus 112 square rooted. So that equals 6.85, and then we divide that by negative 4. So one answer is going to be, and they said what, to the nearest hundredth? So this answer is going to be negative 1.65. And then the other one, clear it out, is going to be minus 4 minus the square root of 112 so that equals minus 14.58, and then we divide that by negative 4. So that guy's about 3.65. So those are our two answers. So again, if you were putting this on a graph at x equals negative 1.65 and at x equals positive 3.65 is approximately where your graph is going to cross the x-axis. Okay. That'll drive me nuts if I don't fix it. There we go. Okay. So as you can see, we got two answers, kind of as predicted. All right, so real quick, let's talk about the discriminant just for a couple minutes, and then we will call it. So again, the discriminant is just the stuff underneath the square root. And I don't actually have a problem here. I'll just make one up here in a second. So let's do, I don't know, we'll do x squared and then minus 2x minus 8, 0, something like that. Just making stuff up. Okay. So the point of the story is this. We're going to work with b squared minus 4ac. So if b squared minus 4ac equals something positive, we have two answers. Okay? If b squared minus 4ac equals something negative, we have 0 real answers. This is where you're going to get, what the heck happened there? There it is. A little lag there. This is where you're going to get the negative under the square root, because this b squared minus 4ac is under a square root. So if we get a negative number, then we have a negative under the square root. That's where that I thing comes in. So there's no real solutions. There's some fake solutions. Actually, I call them imaginary or complex solutions. So this is when your graph is not going to cross the x-axis. Okay. The other one, it crosses in two spots, like the last problem we just did. Okay. And then on the off chance, doesn't happen very often, but it could happen, that b squared minus 4ac equals 0, then we have one answer. And that's when the graph comes down, just touches at one point and goes back up. Okay, so in this case, let's see what we get. So b squared, that's negative 2 squared, that's going to be positive 4. then minus 4 times a, which in this case is 1, times c, which is negative 8. Okay, so you don't even have to get too far into this, because if we look at this, we say we have 2 minus signs here for this part, right? So that means it's going to be plus. So it's plus 32 plus 4 is going to be plus 36. But the point is, it's already 30. It's going to be plus. You didn't even have to really come up with the 36. You can, but you didn't have to. So again, what that means is, since this is a positive 36, we're going to have 2 answers. Okay? So that would be something like, I don't know where my stuff go. Everything just blanked out for a second. Anyway. I don't know where you guys went. That's weird. Hold on. I'll find you. Huh. Honestly, I don't know if you're still there or not. Well, anyway, I was about to wrap up anyhow. So this is going to have 2 answers. So that means you're going to have something like this. And then you're going to have the graph come down and hit in 2 spots. So your graph's going to hit like here and here. Okay? All right, ladies and gentlemen, well, that's all I've got. And like I said, I don't know where you guys went. I can't see you on my screen anymore. I don't even know if you're still here. Hopefully you are, but I don't see you. So we're going to wrap it up. All right. So, like I say, you're more than welcome to go. And I'll see if I can figure out this weirdness that's going on here. And we'll see you all next time.